has several drawbacks. It's annoying for the users to rate items with labels. It's time consuming, and in real application it's potentially inaccurate. So we propose to use an implicit algorithm to detect the emotive responses of users while they are consuming the items. And we aggregate these emotions from several users to get the labels themselves. Sorry. Okay, that's the experiment flow that we did. So we took video sequences of users responding to user items. We performed some pre-processing and extract the registered face. Then we performed the Gabor filtering method to get some low-level features. In parallel, we also extracted a neutral face from the video sequence, and again, we did the Gabor filtering to get the low-level features, and we computed the feature vector for based on these two sets of Gabor features. We used the k nearest neighbors classifier to get the emotive state from a video sequence. In our experiment, we used two data sets. The first data set was the quite famous Canada-Con data set of post emotions. So there are actors who make these expressions, very extreme, exaggerated facial expressions. And the spontaneous data set, which was the one that we acquired. So the inputs were these video streams, and the outputs were the emotive states of users in various responses to the images. The results of this experiment showed that our method showed an accuracy of 92% on the post data set on the Canada-Con, while the accuracy on the spontaneous data set was much lower. And the reasons for the bad performance on the spontaneous data sets are basically we identified three main reasons. One is the weak learning supervisions. The weak learning supervision, which means that we actually, as I said earlier, are not sure whether the emotive response of a user is really that one that we had as the ground truth, because we didn't ask the users. And the other one is the non-really optimal video acquisition, because the users were moving a lot. We had face rotations, occlusions with eyeglasses or hair. The lighting conditions were changing within the recording. And the third one, which is, in my opinion, the biggest reason, is that in the spontaneous data set we had non-extreme facial expressions. Some users really almost didn't show any changes in their faces, so it's very difficult to assess. So the conclusion on the very question of the third contribution, which was whether affective metadata acquired in this method are good for the CBR system, were that no, they are not good for the CBR system. But this answer was really was quite more an intuition more than based on some numbers. After submitting the PhD thesis, we continued this work, and we actually used the so acquired metadata in the same CBR system, and it turns out that the recommender system with affective metadata that were acquired explicitly performs significantly better than the recommender system with affective metadata acquired in an implicit way. But at the same time, the implicit metadata, affective metadata, performs significantly better than just generic metadata. So we have this solution is not the best one, but it's something in between. So it could be used, but there is still a lot to do. So we submitted that paper, and we are waiting for the response. Now let's go to the last scientific contribution, which is the data set that we used, that we built for supporting the first three scientific contributions. Now, the problem statement here, of course, was there were no data sets available to support the first three scientific contributions, so we had to build it by ourselves. The requirements for that data set were that we need to have some content items for consumption. We had to have end users. The items had to be labeled with generic and affective metadata, and the users had to be labeled with their personalities. And of course, we need to have the video recordings and explicit ratings. The data acquisition setup was shown in this slide. First, we explained the user all the purpose of the experiment and so forth. Then the user filled in the IP questionnaire to get its personality assessed. And then the user started using the application that we built in MATLAB. And that application showed a sequence of images. And for each image, the user had to rate the image on a Likert scale from 1 to 5 based on the task of choosing images for his wallpaper. And these images worked, had a twofold meaning. They were both content items to consume, and they worked as emotional stimuli. And at the same time, while the user was using that application, we were recording with the webcam and synchronized the video recording with the application. Just a few dataset statistics. We had 52 users with the average age of 18.3 years old. 37 of these were females. We used the IP questionnaire for assessing personality with 50 questions. And as content, we had 70 color images from the IAPS dataset. And these content items were quite equally distributed in the valence arousal plane. We tried to select this subset to be equally distributed. And this image shows the distribution of the users based on their personality factors. So extrovertness, neuroticism, openness, consciousness, and the fifth one. So as you can see, our users were somehow distributed in this space, although it's very hard to assess whether this sample is really representative of all users available. This is just an excerpt, a video clip from a user that is consuming these items. And this one is very beautiful because this girl has very strong facial expressions. She's now smiling, and I think that she will see something very ugly which she doesn't like, and she makes a very strong facial expression. So this one was quite easy to read. Okay, we are close to the end of the presentation. I will just give you conclusive slides. Now, regarding the scientific contributions, we showed 4 scientific contributions. A new effective modeling method for content-based recommender systems that showed significant increase of performance. A new personality-based user similarity measure for collaborative filtering recommenders, which showed significantly better performance under cold start circumstances. We built an effective image labeling algorithm, which, well, the success is questionable, but anyway, arguable. And we proposed a new data set which is accessible to the scientific community. One conclusion that appears to me is very important is that effective recommender systems are, I would say with this thesis, are becoming a new and important area that connects effective computing and recommender systems. There are several shortcomings in the thesis presented. We are aware of that. One is that we had a quite small data set, few users, few content items, which has several implications. And another shortcoming is that in the experimental part, in the user dataset acquisition part, the task of the users and the task of the recommender system was not very well defined. I mean, it was too general. It should be more specific. And another drawback is that, I mean, it's not a drawback, but it's a simplification, that emotions were treated just as a single attribute of an item, while we know that emotions do change over time quite often. So we suggest for our future work that we observe what are the emotions of the user before he starts consuming, during the consumption, and after the consumption of the multimedia content. The publications, so these outcomes were we published the outcomes in several papers. The main was in the journal article. It was a journal article in the User Modeling and User Adapted Interaction journal, which is one of the top journals in the field. Then we have published a book chapter in a book that will be out in June this year, and then the results were published also on several conference papers. But as we continued this work after the submission of the thesis, we have also an agreement with the LAP publisher to publish the thesis as a separate monograph. We have two more journal articles. One is under review and the other one is accepted, and we plan to submit at least a paper to these 3 conferences. There were, beside the publications, there were additional spin-offs from this thesis. One is the Affective Computing Student Interest Group within the ELDOS laboratory, which started in September 2010, and we are keeping some lectures, journal reading club sessions, and we had also a few student projects. And also based on the work done in the thesis, we were invited, or we managed to get in various proposals. Okay, we had 2 FP7 proposals as coordinators, which unfortunately didn't get funded, but anyway, another FP7 proposal which is due today, and another Interreg proposal which we are still waiting for the response of it's still pending. Now, this is the last slide. I would like to stress that the work presented here is the outcome of not my work, but of the teamwork, So the credit for the work presented here goes to several people. I'm very thankful to all of them, to my advisor, Professor Juri Tkalcic, to Professor Andrej Košir, who also helped a lot, to all the colleagues from my team, from the ELDOS group, to the members of the PhD committee. I'm very grateful to them for their comments. I'm thankful also to the staff and the students at the Gimnazie Poljane who allowed us to make the acquisition of data, and of course I'm grateful to my family and other inspiring people that I met on the way. Thank you for your attention, and I'm giving back the word.
Thank you for your presentation.